Hello everyone. It's really nice to be here today. I would like to present to you today this new open source library that I've been working on with my colleagues for a year. And it's really exciting for me to present it today, because when I was at PyData here last year, we were kind of really starting. We knew that we wanted to help data scientists to handle their workflow. We knew that we wanted to bring pieces that are difficult to add to scikit-learn. We knew that we wanted to provide methodological guidance. We knew that we wanted to do plenty of things, but we didn't really know how and where we should start. When I say this, it may be a bit surprising, because it means that we had the developers, we had somehow a framework of idea, but we didn't have precisely the project and the product we wanted to build. And this is because Skore is the product of a young company called Probable. And Probable is a bit special because it was created, well, before having a product. The goal was to ensure tech sovereignty in AI for Europe and build a startup around scikit-learn. So we had more the framework than the product, which is kind of unusual for a startup. And it was created by many scikit-learn Skore developers, so we can say that Probable is the official home of scikit-learn today. As far as I'm concerned, I work in the product team. I'm a product engineer, and I also run the Paris chapter of Women in Machine Learning and Data Science. Now, to give a bit of context about Skore, it is meant to be a layer on top of 3 other open source libraries that we handle at Probable, which are scikit-learn, of course, in the middle, but also Scrub. You might have seen their presentation earlier this morning, which comes upstream. It's to help handle data preprocessing. And downstreams, we have Scopes, which is a package to handle model packaging safely, without the trouble of pickles. About Skore more precisely, Skore has 2 parts, SkoreLib, the open source and free library, and SkoreHub, the closed source and commercial product. SkoreLib is home for the technical expertise, while SkoreHub is more meant to be home for product sharing, business, and project expertise. Today, we'll focus on SkoreLib, but if you want to know more about Hub, we have a booth over there, and you can come to us, and we will discuss what we're doing with SkoreHub. Now, to the demo time. So, just switching to show you. Apply. Yes. Okay. Maybe I can hide this. Nope. Okay. I hope it will be big enough for you to read, because it's kind of their purpose. To do this demo of Skore, I thought it would be nice to take a Kaggle problem. So I went on the Kaggle platform and chose basically one of the most recent competition with tabular data that had been posted. So it's a very new challenge that was posted like now 1 month ago. I downloaded the data and unzipped it, not the most interesting for us today. And so now we can start by fetching it and splitting. So I'm fetching. Yes, about the competition, the goal is to predict the melting temperature of molecules based on some information that we can have on the molecules. The first feature that we coded in skore was a revamp somehow of trench split. It's not a huge revamp; it's just a layer. And our idea was that trench split is the most used function, at least based on the analytics and the docs of scikit-learn. But although it's a very simple function, it may be used with creating some trouble in the pipeline. So we created some warnings. Maybe the wording is not great. We should come with another name, because warning is in general what you do on the top. You write the ignore warnings, which is not something that we should do, but that everyone does. So coming with another name, and the idea is to give methodological advice to make sure that it's properly used. Here, for instance, I have a shuffle warning. It says that we detected that the shuffle parameter is set to true, either explicitly or from its default value, because by default, the shuffle parameter is set to true, and it can be a problem. Why? Because it means that if I have time-ordered data, then I will use data from the future to train and predict on the past. Even though I may suppose that my events are quite independent, for instance, if I'm trying to predict churn of a customer, the fact, if I'm in a big B2C company, the fact that one customer churned in September might not affect, or very rarely, the churn of a customer in December, because the likelihood that they talk to each other is very small. But it's still hiding a data drift that I may have. So it's, even though I can suppose that broadly my events are independent, in reality they rarely are, and it's nice to not do shuffle. Except here we are in a chemical problem, so I can basically suppose that for kind of centuries or millennia at least, the laws of chemistry will not change, and I'm safe. I can go on. Also, my trench split function can return, if I asked it to, a dictionary, which is nice because I don't have to go check the doc if it's X train, Y train, or X test, X train, X test, and the order of all my elements. It's just a dictionary, so it's cool. Since I'm doing a Kaggle competition, I'm just not minding the data first at all. I will just run a very nice baseline that I hope I can score well on the leadership board correctly. So I will use, the tabular pipeline by Scrub. Here we are in a regression case, so don't even bother to choose the model. I just tell Scrub, use the best regression model you have. And Scrub baseline looks like this. So it has the preprocessing inside what we call a table vectorizer and the histogram boosting regressor. Now, about the first main object in skore, it's called the estimator report. I will just have to give to my estimator report my baseline and my splitted data. It will handle then after everything for me, including the training. It will be done inside it. This object has a helper to make sure I can easily access everything that's inside. And I can see here, so I have accessors, and I have some kind of middle objects, if you want, to access plenty of elements. So from my estimator report, I could ask the prediction error, my R2, RMC, If I want also to know more elements about the timings, the time it took to train and to test, and plenty of elements that we will discover together in this demo. Just a small function to, because I will do that several times, to create my Kaggle outputs, and I will use my estimator. My model is inside the estimator report. I can get prediction from a new source, which is my evaluation set. Then I have some formatting to give it to Kaggle nicely. I create my Kaggle output, and then I submitted it. I already submitted it, so I can know that my submission score is 33.9 on the public leaderboard. When I check the leaderboard, I see that the base score today, well, it's not today, actually, it was a couple of days ago, but back then it was 7.10, and the SOTA is 20. So I definitely know that my baseline is not what we could do best, and I can improve it. Okay. What should I do to improve my model? It's obviously to start exploring the data. If I want to improve my model, I have to dig into the data to know what's inside. To do that, I will use the data accessor of my estimator reports, and I have a function over it that I can call that is analyze, and it will output what we call table report display. And so it's a display, and I can then after I can display it. It's in the name in my notebook. So it's the table report. If you were here at the script presentation, you will see that it's what Ricardo presented. I have plenty of information about my dataset. What I learned here is that, well, I have quite a few columns. This is why it took a bit of time. I have the smiles feature, which is the writing of a molecule, so way to write a molecule in 2D. And then I have plenty of integer features that are, I don't really know what, and they're all integers. What I can be also interested about is checking the distribution of my target. So I can see that over here, the melting temperature. So I have just one outlier according to Scrub. So it means that I don't have to worry too much about it. It will not. It shouldn't affect too much my performance of my model. And basically, it's so it's in Kelvin, and it's around 300 degrees, which is kind of expected. So okay, nice. It's interesting. To improve my model, I think that all the group N features, I can't do much about it. They're just integer. They're treated as they may be. But maybe what I can do is working something on smiles. From my very basic chemistry knowledge, I suppose that having a given number of carbons will affect the melting temperature, the number of oxygen, nitrogens, also how number of double bonds that are written with an equal in a smiles writing, and the number of triple bonds, which is with a hashtag. So creating this new feature, I'm train test splitting again with this new dataset enriched, and giving it to a new estimator. Now to the second object in the score, it's the comparison reports. It's cool. I have my first baseline. I have the enriched one, the enriched model, and I would like to see which one is the best. I give it to comparison reports. And that comparison reports, it also has a helper. Our goal really was, with our reports object, was to have really the same structure across all of them. So once you get used to one, it gets very easy to use all of them. In that comparison report, I have my metrics. I can cache prediction, do some elements. And here, what I want to do, since I want to check which one is the best, is obviously checking the metrics. Taking the metric summarize will also output a display on which I can call frame to display it like a data frame. I see the R2, the RMC, and it seems to say that my baseline is doing poorly compared to the enriched model based on these two metrics. I also have a short reminder of the favorability in case I want to share it with people either junior or who are not used so much about these metrics. It's nice, but on Kaggle, it's not these metrics that are used to evaluate. It's the mean absolute error. So I'm going to give to my comparison reports the MAE to check if I should choose my best model being the enriched one or the baseline. And here it shows that the enriched model is doing better, so it's nice. I can send it also to Kaggle. My new submission scores 31.6, so it's nice, it's a bit better, but it's not like hugely better, and I'm still not at the SOTA. So what can I do about it? And what can I do about it? And how can I start understanding a bit better to maybe to have leads about how I could have a better model and reach maybe SOTA or the top level of the leaderboard. In my, if I remind you, in my helper, I had the feature importance, and for some model we have other elements such as coefficient for linear models or MDI for trees, but here, in my case, I just have the permutation available, so I will use that way to do feature importance. Since it's kind of not huge data set, but it has a very high number of columns and permutation goes per columns, I only did ask to do 2 repetitions, and I'm not doing it over my whole data set. What I'm interested in is to see the evolution of the MAE, so I can give it to the parameters of how the permutation is computed, and obviously trying to speed it to the maximum, the number of job -1, and it should take around, when I did test, it should take again 20 seconds more to compute, because, well, feature permutation is one of the longest time, so we can't wait to have the answer yes. So now that I have it, I can display it thanks with a nice plot. So it's telling me that the smiles function feature is the most important. It looks like there is a group function over here that is also interesting. And this last function, it's the function I suppose that I added. If I want to check it, I can use this display with its data frame form, doing some aggregation. What I want to know more exactly is the sorting, just check the most important. And I can actually see that 1, 2, 3, 4, 5, 6. It looks like the model only relies in basically 6 of these features. Maybe I want to take the group 15 because this is maybe a feature I can even improve. If it's important, it means that it contains information, and maybe I can go a bit, do a bit better with some pre-processing. So I want to know what's inside. Inside my reports, I have stored my data set, so I can access it, the X-train, check the group 15 feature and describe it. Okay, so it looks like that. I can check my value counts. Okay, I have around 15 different values. Interesting, but so far it doesn't give me any idea, so maybe there is a linear relationship to the target. let's check. So here I'm using my display, my data display that I created above, that I could display a table report, but I can also call a plot function over it, so I don't have to write all of the whole function to display data. And I want to plot this x against y. From this, what I see from this plot, well, I don't really have any specific idea of what I can do with this feature, so I will keep it as is. So I will focus actually more on another preprocessing about doing with a smiles feature and doing maybe checking if other parameters in the string encoder might be helpful. So I have this new pipeline. Again, I give it to an estimator report with split data, and I want to compare now my baseline enriched and the modification of the string encoder that I have here. Okay, so my string encoder seems to be performing a bit better, but I would like to check the stability of this because since this improvement is quite small, in the leaderboard it can be erased and it can even come backwards and perform actually worse. So is this improvement better? I will do obviously cross-validation to check this. And here, the third and last object, the third and last report that we have in SCORE is the cross-validation report. So I just have here to give it my estimator, my data. This time I don't have to give it splitted, it will handle it by itself. And the splitter, here I chose to do a very short splitter with 3. And by default it's doing just very usual k-fold. But I could give it any kind of splitter that exists as long as it respects the scikit-learn API. And again, my comparison report, because my comparison report can handle both a cross-validation report or an estimator report, and checking the results. So here, this time it looks like my enriched model is indeed performing a bit worse than the string encoder, with the standard deviation better for the string encoder. So it looks like I should choose a string encoder to go to Kaggle. Spoiler alerts, when I do that several times, the results are not the same, so repeated k-folds would be much better, but it's not compliant with the time we have here. Going back to the slide, it was the end of the demo, and you saw here that what we are aiming at is to ease the way to create data science artifacts which contain many things, helping data scientists to access quickly and easily with little code, and therefore we hope little bug, plenty of elements, guiding them with methodological advice. And also these artifacts, we can share them easily through a hub or even in local. So it's, we hope, easy to collaborate inside a data science project. We will have a sprint session tomorrow for scores, so if you want to come and say hi, we'll be very happy to see you, and thank you for your attention.
Thank you very much for the presentation. Are there any questions in the audience?
Thanks for the nice presentation. I had a question regarding the overall aim for SCORE. Is it to come up with the best practices that are generic for a data scientist persona, or does it also aim for having best practices and, well, even caveats as what you show showed with the warning that was specific for time series data that are data specific. So is it model specific or modeling specific, or can it be also in the future data specific and not giving warnings that are not interesting for someone that works with some kind of data when he's using it? Thank you.
The goal is to be generic and to use the data to provide interesting elements. So for instance, it's why we didn't go for a linter, because the linter doesn't access what's inside the data, and it will fall short in many situations. Why are we keeping this shuffle warning in place? Is because basically, except when it comes to chemistry or physics, you will always have time order data, even just in the way you sampled and detected your data. So in like 99% of cases, actually, it will be relevant.
Are there other questions? Yes. Trying to find the easiest path.
Thank you for a wonderful talk. I have a question about integration with experiment tracking system. What types of tracking system, for example, MLflow, ClearML, or ours, SCORE have built-in integration with?
Yes, it's one of the questions we are asking ourselves today. How do we live in this space of experiment tracking, and how can we be compliant and integrated into what exists today? Most of you already are using a tool, so the goal is not to replace, but add help wherever we can.
Other questions? Maybe a question on my hand. So during the demo, you showed some operations that are quite computationally intensive, like the computation of the distribution and the statistical association between the features in the table report, or the feature importance analysis. So when you're doing interactive development like this, waiting 1 or 2 minutes is fine, but maybe 30 minutes might be too long depending on the size of the data and the model. Do you have plans to improve on that?
Yes, we would like to be able, once these kind of artifacts are pushed to SCORE Hub, the idea that it could be triggered on SCORE Hub, so you can continue working on your laptop without having impact. And when the results are ready, then you can see it on the platform without having to do computational intensive stuff on your laptop, which is obviously limited.
So thank the speaker again.